Okay. Hi all, welcome to PR classes. So in last video, we saw about material cost variances. Now we are going to see on labor cost variances. Labor cost variances. So the graph, right, which I said ultimately remains the general structure of the graph remains the same. So the labor cost also we have like x-axis and y-axis. X-axis, y-axis. And in material, we used the word like SP and AP, correct? Standard price and actual price. The same concept only, it's a price only, but we are not going to use the word price for a labor. We are going to use the word called rate, but the concept is remains the same. So we are going to use the word called rate, SR and AR. Actual rate, standard rate. Similarly, standard first, actual second. Price in y-axis. Instead of price, you are going to use the word called rate. Similarly, quantity. In labor, you are not going to measure as quantity. Metal will measure as quantity. Labor is how much hours you worked. So standard hours and actual hours. Understood? So price you are going to replace with rate, quantity you are going to replace with hours. The same thing. Yeah. With the joining of the graph, everything will remain the same. SR into SH, SR into SH, SR into AH, and AR into AH. AR into AH. Okay. So this box, what we showed there, price variance. Now we are going to use the word rate. So this is called as rate variance, labor rate variance, the difference between the standard rate and the actual rate. Now next, this box. There we showed us usage. But for labor, right, we are not going to use the word usage. We are going to use the word efficiency. Efficiency. Understood? Now what is the labor rate variance graph formula? SR into AH, this box. SR into AH minus AR into AH. Labor efficiency variance, this box. SR into SH minus SR into AH. This is why I said in material cost variance. If you don't understand that graph, subsequent all the graph, like we are going to follow the same approach. Now this is like all as for metal, what we did without the mix, we showed it said that is for a single material. In labor, we are not going to tell it a single labor or two or more. We are going to group the labors as gang. For example, when the mix variance will occur, when there are two or more gang, two or more gang. If there are, just understand this small concept in labor, there are 100 labors, and all the 100 labors are being grouped as skilled, single group. Then there is no mix variance. This is the graph will how it looks like. But there are only 10 labors. Out of these 10 labors, 5 are skilled, 5 are semi-skilled. So there are two gangs. There is only one gang of 100 workers. There are two gangs. Since there are two gangs, now you will have a mix variance. Able to understand? Let's put it here. So this is without ideal time. Without what is ideal time? I'll explain in the next sometime. Ideal time. This is graph for labor cost variance without ideal time for single gang. For single gang. If there are multiple gangs, two or more gangs, then there's a concept of mix. Now what will happen if the mix is there? The efficiency will be divided into 1 minute, two category. One is my yield, other one is the mix. This is for multiple gang. or 2 or more gang. Understood? Now let's go by the formulas. Labor cost variance. So this separation point is called as RSH. RSH. There we showed as RSQ, the same concept only, RSH. There the definition is total AQ in SQ ratio, here total AH in SH ratio. Same thing only. The concept remains the same. So now the labor cost variance, you are separating into labor rate variance, labor rate variance, and labor efficiency variance. Labor efficiency variance. Then labor efficiency variance. When there is a single gang, that's all. When there is a 2 or more gang, what will happen? We have the gang variance, then the efficiency is further split into labor yield variance or labor mix variance. Labor yield variance. Labor yield variance is also called as labor sub-efficiency. Other one is the labor mix variance. Labor mix variance is also called as labor gang, since they are called as gang, right? Gang variance. This is R only. R. Labor mix variance is also called as labor gang variance. Labor yield variance is also called as labor sub-efficiency. Only the naming terms, we have like 2 names for the single concept. Now let's go by the formulas. Labor cost variance. Just someone come, unmute yourself and tell the formula. What is the labor cost variance? Come on, let's give a try. Just come forward. Because I need to pick
SR into SH.
SR into SH.
Minus AR into AH.
SR into SH minus AR into AH. Next, someone from the next, another person try. The person who tried, no need to tell again. Another person give a try for rate variance. Give a try. Or else I need to pick some names. Come on.
Sir, SR AH minus AR AH.
SR into AH, right? Minus AR into AH, correct. Now labor efficiency variance. Any other person?
SR into SH minus SR into AH.
SR into SH minus SR into AH, super. Now labor yield variance. Yield variance, the new person. Any new person try? Come on, just unmute yourself and tell the formula. That's it, right? I'm not asking any other questions.
SR into SH minus SR into RHS.
SR into SH minus SR into RSH. Super, correct. I can't see your names who is telling. So now the mix variance is last person. One. Everyone thinking someone will tell and everyone is unmuting yourself, right? Give a try. Hello. Jitin, you're there, right? Can you try? Come on, so many people are there. Just give a try. Where's the table? I'm not going to move forward without someone telling it.
Sir, SR. Sir,
yes.
SR into RSH.
SR into RSH
minus SR into AH.
minus
AH.
SR.
Minus SR into AH.
Super, sir. Into AH. Correct.
AH.
That's all. We derive the formula, sir. Now let's see what are the terminologies. SR is standard rate. Standard rate. AR is actual rate. SH is standard hours for actual output. AH is actual hours. SH, when it comes, always use it tell SH is standard hours for actual output, similar to SQ, standard quantity for actual output, right? Same logic, standard hours for actual output. And then last one is RSH, total AH in SH ratio. That what we saw RSQ, total AQ in SQ ratio, right? Here total AH in SH ratio. Now let's see next one sum. Now this we are seeing without idle time. Now we have the same like similar two graphs as for with idle time. I'll explain it after solving one sum. Sum number 4. Where variances. I'll read the question. The standard labor complement and the actual labor complement engaged in the week for a jobbers are under. So they're given the data for standard and actual. So what is the standard number of workers? Skilled, semi-skilled, unskilled. So you can see there is skilled, semi-skilled, and unskilled. So there is a possibility of gang variance. So because there are three groupings are there. So which graph you have to follow? This is only for single graph. This is for multiple graphs. So this graph you have to follow. Since there are three gangs, there's a possibility of mix or gang variance. The standard number of the workers in gang is 32 skilled, semi 12, unskilled is 6. Standard wage rate is 3 to 1 per hour rate. Actual number of workers is 28, 18, 4. Actual wage rate is 4, 3, 2. Everything they are directly given in the question. Standard workers, standard wage rate, actual workers, actual wage rate. Now you can see how many weeks are there. During the 40-hour working week, the gang produced 1,800 standard labor hours. So they are given directly. The standard labor hours is 1,800. Usually in labor cost, if you write, right, for SH calculation, mostly they will given the question. Certain sums only we have to calculate the SH. Mostly they will give in certain in this sum also they are given. So the total standard hour is 1,800. You have to split it into skilled, semi-skilled, and unskilled. That's what you have to do. That's not major calculations over here also. And second thing, right, what I want to mention here, by hours, I don't mean hours or labor. It means labor hours. So you can see here, there are 40 hours worked and there are 32 labors. So it means the total hours which for SH you are considered is 32 into 40 or something. So this by hours, I mean it is labor hours. This actual hours is actual labor hours. Okay. So by hours, I mean it is labor hours. Just remember that one point in your mind. Now let's do the solve the sum. So this is multiple gang. I just put the graph here for ease understanding. First one table, just combine all things. SR into SH, SR into RSH, SR into SH. First one SR into RSH. Same like how we did material. SR into AH. Last one is AR into AH. There are three kind of categories: skilled, semi-skilled, unskilled. Now what we are going to do? We are going to fill in the data that is available in the question. Standard rate per hour, 3 to 1 given in the question. So 3, 2, 1. Just put it for all the standard rate. Next actual rate, 4, 3, 2. So what I did, I just took the number, standard rate and actual rate. This SH is what I said as before. That is standard labor hours. It's not hour. The given it's you have to multiply the number of labor into hours. Similarly, AH is actual labor hours. You have to do the calculation. Let's see. Working notes. So AH for skilled. Labor hours. I again repeat, it is labor hours. How many labors are there in actual gang? 28. Skilled is there. 28. How many hours are there for the week? 40. So 28 into 40. 1120 labor hours. Okay. Similarly, AH for semi-skilled. How many semi-skilled labors are there? 18. How many hours they have? 40. So labor hours. 720 labor hours. AH for unskilled. How many unskilled labors they have? 4. How many hours they have for this week? 40. 4 into 40. 160 labor hours. Just put it here at actual hours. 1120, 720 and 160. 1120, 720, 160. Now for standard hours. SH. As I said, right, the standard labor hours, labor hours is already given as 1800. They are given in the question. So the standard labor hours is 1800 labor hours. How you got it? Given in the question. For the understanding, I just put it here. Given in question. Directly they are given. So now what you are going to do, this 1800, we are going to split into skilled, semi-skilled and unskilled based on number of workers. So what I'm going to do, I'm going to split this into skilled, semi-skilled and unskilled based on the number of workers. In skilled, how many workers are there? 32. Semi-skilled it is 12. Unskilled it is 6. So based on this ratio and based on the number of workers, I'm separating it. So 1800. So how many? What you'll do? If you add 32 plus 12 plus 6, it is 50 labors. So 1800. If you have divided by 32, sorry, 1800 number of equation. 1800 divided by 32 plus 12 plus 6 divided by 50 into, for skilled it is 32. Same ratio logic. 1152. Here it is 12. Here it is 6. So totally 1800 labor hours are there. I'm splitting the labor hours into number of workers. So I'm getting the labor hours. Put it in SH 1152. How much here you got? 432. 216. Okay, we found out the standard hours. Next, we have to find out RSH. What is RSH definition? Total AH, not SH. Total AH in SH ratio. What is my total AH? I have to sum all the AH value. All the 3 AH values I have to sum. Where is it is 1120 plus here we found out AH, right? Plus 720 plus 160. $2,000. What ratio I'm going to split into SH ratio? What is the SH ratio? Now you have number 32, 12, 6. The same logic which we followed here. 32, 12, 6. I'm just splitting it. So instead of 1800, I'm going to follow 2000. So total AH I have found at 2000 labor hours. What I'm going to split the total labor hour 2000 in SH ratio. What is my SH ratio? Standard number of workers 32, 12, 6. 32, 12, 6. So you get 1280 RSH 1280, 480 and 240. Just put the total. I got the values. Now let's put the formulas and try to complete this. Labor cost variance. Labor cost variance formula, overall cost variance, SR into SH minus AR into AH. Put here. SR into SH minus AR into AH. Next, labor rate variance. Formula, SR into AH minus AR into AH. SR into AH minus AR into AH. Next, labor efficiency variance. Labor efficiency variance. Efficiency variance. Formula is SR into SH minus SR into AH. SR into SH minus SR into AH. SR into minus SR into AH. Next, labor yield variance. Labor yield variance is also called as labor sub-efficiency variance. SR into SH minus SR into RSH. Next one, labor mix variance. Labor mix variance is also called as gang variance. Remember, the word gang variance is predominantly used over mix variance in this. Okay, for labor variance, usually for 2 marks, if they ask, they prefer to ask by labor gang variance. So labor mix variance is also called as labor gang variance. Just make sure know that. So SR into RSH minus SR into AH. So now all the formulas has been derived based on this small one graph. Okay. So labor cost variance SR into SH minus AR into AH. How much it is? 2424 unfavorable. Adverse. Labor rate variance is SR into AH minus AR into AH. This is also unfavorable. Adverse. Efficiency variance is SR into SH minus SR into AH. This is also adverse. Don't put negative sign, I said, right? If it is coming negative, just put the same value and put bracket adverse. Yield variance is SR into SH minus SR into RSH. All the variances are adverse only coming. Let's see. Labor mix variance is SR into RSH minus SR into only one favorable. So now how you will read this? So labor cost variance, overall we paid more labor cost than we expected, 2,424, which is adverse, of which the major adverse is coming from the rate variance. We paid more rate labor wage than what the standard wage rate. See, right? So the rate is the higher amount. And because of the labor efficiency, we see there is a slight drop, like 424 adverse, of which their main yield efficiency is 504 adverse. And due to the labor mix, the mix between skilled, semi-skilled, and unskilled, right? That mix, we see some favorable impact. So only because of the mix, we see some favorable. Other than that, there is less because of labor efficiency. There is a drop in the value. So that's or increase in the cost, or drop in the efficiency. Both are same, right? 504 adverse, and there is increase in the wage rate. We see 2000 adverse. This is how we have to read the result, interpret the result. Any doubts in this sum before moving on to the next sum? With that will be with ideal time. This is without ideal time. So in the sum, right, they did not give anything called as ideal time. So any doubt in this sum? Just unmute yourself and tell. Okay, if no doubts, I'll go to labor cost variance with ideal time. I'll go to the same main sheet. So this we saw without ideal time, right? Now we are going to see with ideal time. So what is meant by ideal time? So you want to understand the definition of ideal time. So we are not machines, we are all human beings. So we need some time to relax ourselves, or there will be some machine breakdown, sometime where we don't work, right? So that is called as ideal time. For example, if we are going to work at 9 and come at 6 o'clock, so there's 9 hours work, but we have like 30 minutes of lunch break, 15 to time for 15 minutes of tea break. Then, so 1 hour will be going like in ideal time. So this time is called as ideal time, or sometimes you'll go for 8 hours work, there'll be 4 hours machine breakdown, correct? And you will not be working. So that is called as ideal time. So which time we don't work, it is called as idle time. So when there is an idle, why we have to calculate the idle time? I will tell you example. For example, there is 8 hours work. So just put the numbers over here. Just you'll calculate for easy purpose. You'll take it as single day calculations. 8 hours work. In 8 hours work, 4 hours is machine breakdown. 4 hours is machine breakdown. Balance 4 hours only you are working. 4 hours machine breakdown happened. Breakdown happened. Balance 4 hours only you are working. 4 hours only you are working. So in 8 hours work, your standard units you will produce is 100 units. Now 4 hours machine has been broken down. So you did not work. So balance 4 hours only is available. So in this 4 hours you produced 50 units. Got it? So in 8 hours work, you have to produce 100 units. This is the standard which is fixed for you, but 4 hours has been machine breakdown. So 4 hours only you are working. So in this 4 hours, you completed 50 units. So your efficiency is 50% or 100%. Just tell me. Someone come on unmute and tell your efficiency is now 50% or 100%.
100%.
Why 100%? So the person who said 100%, why 100%? Who said?
Because the standard for 8 hours is 100 units, na sir. So for
Correct.
standard unit production for 4 hours would be 50 units.
50,
And
correct.
since we produced 50 units, so the efficiency rate would be 100%.
100, correct. So this is actual hours worked. So this is the hours you worked, correct? So the efficiency you are calculating on hours worked. Now come to the salary portion. For the day salary, for the day you are going home, you are getting the salary and getting. So for 8 hours, one day, your salary is 1,000 rupees. You will get 1,000 rupees or 500 rupees. How much you will ask?
1,000 rupees. 1,000 rupees, sir.
Because this 4 hours is machine breakdown only, correct? You have been idle,
No
but
doubt.
that's little machine breakdown. So this payment is for actual hours paid. For payment, you will take it as 100. For 8 hours, you will be taking the full consideration. For efficiency, you will be considering only the 4 hours, correct? For payment, you will be considering 8 hours. But for efficiency, you will calculate the 4 hours. Just have this in your mind. Now we are going to the graph. So why I explain this, you will be quite knowing now once I put the graph. Let's put it on this out. Similarly, single gang, multiple gang, same concept only. Single gang, if there won't be mixed variance only. I'll take this graph itself, or else you will have many graphs. The same graph, what I'm going to do is rate variance. Just 1 minute. One minute, I'll put the graph and explain it. Okay. Now the same graph only, SR into SH, SR into RSH, SR into AH, which we saw in the above. But here, what I am going to do, I am adding another column that is called as for idle time. This is called as AHP. And this is AHW. So what I'm doing is I'm splitting the actual hours into actual hours worked, which we saw here, and actual hours paid. So the difference between actual hours worked and actual hours paid is the idle time, which is just link this example which I said to here. So the difference between actual hours worked and actual hours paid is idle time. So now, as you said, right, the efficiency you will calculate only in 4 hours, which is the actual hours worked. So the efficiency is calculated with respect to AHW, which is actual hours paid, correct? So the salary is calculated with 8 hours. That is the actual hours paid. So the salary, the rate is calculated with AHP. And able to link. So the efficiency calculated with the AHW, as we said, right? For the how much hours you work, only you're going to calculate the efficiency. The efficiency is actual hours worked, but salary is on actual hours paid. So only see the rate I just put linked with AHP. The delta between worked and paid is the idle time. Any doubts in this graph? This is for multiple gang with idle time. If it is single gang with idle time, means what will happen? Same graph, there won't be yield and mix. This fully will be efficiency variance. That's all. There won't be RSH. Same concept only. If it is single gang, but idle time, this everything remains the same. Only the RSH won't be there. This totally is called as efficiency variance. This is multiple gang, so we have like yield and mix. Okay, now let's go to the formulas. I'll just copy the labor. So the labor cost variance formula, what will happen? SR into SH minus SR into AHP. You can see here, right? AHP. So there will be changes. AHP. Labor rate variance, SR into AHP minus AR into AHP. This box. SR into AHP minus AR into AHP. Labor efficiency variance, this box. SR into SH minus SR into AHW. As I said, right? Actual hours worked. Yield variance, SR into SH minus SR into RSH. There won't be any change. Mix variance is SR into RSH minus SR into AHW. Now you have a new variance called as idle time variance. Let me put this further right. So there will be like labor efficiency, labor rate, and third one will be labor ideal time variance. Labor ideal time variance. Now, anyone try the formula for ideal time? By this time, you would be an expert in deriving the formula out of graph. Anyone try the ideal time formula? Just come, unmute yourself, and just tell the formula for ideal time. Don't be shy. Just be active. Be an active participant.
SR into AHW
SR into AHW
minus SR
minus
into AHP.
AHP. That's it. Easy only, right? You derived from this graph. No need to remember the ideal time formula and all. Just if you know the graph, you can just take it out from the extent on the graph. If it is single gang, what will happen? I'll just put it here. For single gang, what will happen? For your reference. For single gang means what will happen? Same graph, there won't be a yield and mix, correct? Everything will be only efficiency. There won't be RSH. Idle time concept and all will be same. If for single gang with idle time. Multiple gang with idle time, same. So there won't be like labor rate, efficiency, and idle time. There won't be yield or mix variance. That's all. Okay, right? I will move on to next sum with labor cost variance. That will be with idle time. Next sum. Okay. Someone, I think, just unmute yourself. Okay. I'll read the question. The following was the composition of the gang of workers in a factory during a particular month in one of the production department. The standard composition of workers and the wage rate per hour were as follows. So this is the standard: skilled, semi-skilled, unskilled. 2 workers at the standard rate of 20 per hour. 4 workers at the standard rate of 12 per hour, 4 workers at the standard rate of 8 per hour. So the standard rate is 20, 12, 8. Standard hour is labor hours, as I said. We have only the labor hours we require, right? You have to multiply it, right? Let's see how we calculate that. In the sum, the such calculation is quite challenging. Let's see. Last sum, they are given the total standard labor hours, right? But in this sum, you have to do the calculation. Let's see. Next, the standard output of the gang was 4 units per hour. So the output for the gang is 4 units per hour. So for 1 hour, they produce 4 units. During this month, the actual composition of the gang and hourly rate was 2 workers at 20 per each, 3 workers at 14 per each, 5 workers at 10 per each. This is my actual number of workers, 2, 3, 5. Standard is 2, 4, 4. Standard rate is 20, 12, 8. Actual rate is 20, 14, and 10. The gang was engaged for 200 hours during the month, which included 12 hours when no production was possible due to machine breakdown. So when we given like this, right? So you should understand. So 12 hours, there is no possible product hours, working hours due to machine breakdown. So ideal time is that this 12 hour is ideal time. So ideal time variance is you have to be calculated. So explicitly they won't give calculate ideal time variance and all. In question itself, based on this line, you should understand this sum is an ideal variance sum. Okay. 800 units of finish of the product was recorded as an output of the gang during this month. So the output is 810 units. Because for SH calculation we have to do. So in the sum they are given the output. Calculate the labor variances. If they are given like labor variances, you have to calculate all the labor variances. So multiple gang are there. So this is multiple gang. Ideal time is there. So this is the graph. Let me take the graph and put it here. Now first one, the computation table. SR into SH. SR into RSH. SR into AHW. SR into AHP. Just I'm copying it right. SR into SH. SR into RSH. SR into AHW. SR into AHP. Last one, AR into AHP. AR into AHP. Now you have skilled, semi-skilled, unskilled. Now what we are going to do, what all data is available to us, readily available, fill the data. Standard rate I say is 20, 12, and 8. 20, 12, and 8. All the lines are linking with standard rate, so you can see all the standard rate is updated. Actual rate is 20, 14, 10. 20, 14, 10. Now let's see what and all you can be able to solve. Here I missed one thing, right? Sorry. SRH, you have to see the definitions, right? For this, SR we saw, AR we saw, SH we saw, AH we saw, RSH we saw. But here we are going to separate AH into AHW and AHP. So AHW is actual labor hours. By hours I mean actual labor hours. Actual labor hours worked. AHP is actual hours paid. Now the RSH definition, what we have seen here, total AH in SH ratio. Now what is near here for the mixed variance? AHW, so that it changes total AHW in SH ratio. You can see here, right? RSH, what you calculate total AH in SH ratio. Here, what is near RSH? AHW to calculate the efficiency. So RSH is total AHW in SH ratio. Other thing is the same. SH is standard hours for actual output. SR is standard rate. AR is actual rate, which I already given here. Okay. Let me jump here. So what is AHP? Working notes. AHP of skilled, semi-skilled, unskilled. What is my actual hours paid? So how many hours are there? 200 hours are there. As I said, right, 12 hours is ideal time. So the actual working hour is 188, but the salary you are going to pay is for full 200 hours. So the actual hours paid is for 200. As I said, this is what labor hours. So what is my actual labor? You can see actual hours paid. I should not take now standard labors. I should take actual labors. It is 2 labors for skilled. 2 labor into what many labor hours? 200 hours. Sorry, 2 labor into 200 hours. If I do it, it is 400 labor hours. 400 labor hours. Similarly here, 3 into 200. 3 workers semi-skilled. Here it is 5. 3 into 600, 1000 labor hours. Just put it in AHP. 400, 600. 1000. 400, 600, 1000. Now actual hours worked. How much actual hours you have worked? I put it here. AHW. So there's 200 hours. It is your full time hours. Out of which idle time is 12 hours. So 200 minus 12 is the 200 minus 12. Correct? So total hours available is 188 hours. But you require labor hours. So how many labors are there? 2, 3, 5. Instead of 200, now how many workers hours you are working? 200 minus 12, 188. Semi-skilled, unskilled. You understand, right? How I got this 188? Just the total working hours is 200 minus 12 is idle time. So the actual hours worked is 188. If I multiply 2 into 188, this is 3 into 188, 5 into 188. Actual number of workers you are taking. AHW, actual labor hours. So actual labors. So 376, 564, 940. Now comes to the tricky part as such. 100 hours for actual production. By SH, what I mean, standard labor hours. So you can see here what they are given is the standard hours output for the gang was 4 units per hour. Remember, this is here you have to crack it. 4 units per hour, whatever. It's only an hour they given, but we require labor hour number, right? So 4 units per hour. The actual output is 810. I should not just use directly the 4 divided by conversions and all because I require labor hours. So I need to factor labor also into it. So how we am going to do? So just be attention over here. So for skilled, how many labors are there? 2 labors are there for skilled, correct? Hour they given is for 1 hour. So if I multiply 2 into 1 only, I'll get labor hours. 2 labors, 1 hour, correct? In this, I produce how many units? 4 units. So actually, in 1 hour, I produce 4 units, but the calculation I required is labor hours. So I need to calculate the labor hours. So in 2 labor hours, I provide 4 units. So there is a difference, right? So you have 1 labor, 1 hour. In that 1 hour, 2 labors are working. So how many labor hours you should have? Because of 2 labors are working, you have 2 labor hours. That's what you are going to find. So 2 into 1. This is the important calculation you are going to into. So totally, how much is my output? 810. So 2 labor hours, units gets cancelled, you will get labor hours. So 2 divided by 4 into 810. So 405 labor hours. I'll explain again through unskilled labors, unskilled. So for 1 hour, you produced 4 units, but I require labor hours. In semi-skilled, how many labors are there? 4 workers are there. So labor hours is 4 into 1. So in this 4, so in 1 hour, we have 4 semi-skilled work. Semi, right? Semi-skilled only 4, right? Correct. Semi-skilled 4. In 1 hour, there are 4 semi-skilled workers. Totally, it gives 4 semi-skilled labor hours. On 4 semi-skilled labor hours, you produce 4 units. How many labor hours you require to produce? 810 units. So 4 divided by 4 into 810, you will get simply 810 labor hours. Similarly, unskilled. Same calculation. Only 4 unskilled are there. Same calculation. 4 unskilled, 4 labors into 1 hour. 1 into 4 labor hours, you produce 4 units for 810 how much? 810 labor hours. So this is the number. 405, 810, 810. 405, 810, 810. Now come to definite RSH. RSH is what I said here, what we said, which is nearer RSH. Total AHW in SH ratio. Total AHW in SH ratio. I put it here. Definition, write the definition first. Total AHW in SH ratio. So what is my total AHW? Total AHW. Where is the AHW? 376. 564 plus 940. If I sum it up, 376 plus 564 plus 940. 18. 376, 564. So 1880. In SH ratio, what is my SH ratio? See how many labors are there? 2:4:4. SH ratio is total AHW. SH ratio is 2:4:4. Now separate this AHW and SH ratio. Skilled, semi-skilled, unskilled. What I will do? 1880 divided by 4, 8, 9, 10 divided by 10 into 2 into 4 into 4. 376, 752, 752. Just this 1880, I'm just dividing into, apportioning into SH ratio. What is SH ratio? 2:4:4. 376, 752, 752. 752, 752. That's it. Now let's solve the now. Let me try if I do like this. I'll like it. Okay, we got the answer. Now let's put the formula and close this. First one is labor cost variance. What's my labor cost variance? SR into SH minus AR into AHP. SR into SH minus AR into AHP. Next, labor rate variance. This box. SR into AHP minus AR into AHP. SR into AHP minus AR into AHP. Next, labor efficiency variance. Labor efficiency variance. This box together. SR into SH minus SR into AHW. SR into SH minus SR into AHW. This efficiency is again split into labor yield variance. Labor yield variance, other name is labor sub-efficiency variance. Formula is SR into SH minus SR into RSH. RSH. Next one is labor mix variance. This is yield variance, right? Yield variance or labor sub-efficiency. One it is labor mix variance. Labor mix variance or labor, what I said, predominantly what word did you use for mix variance in labor? Gang variance. SR into RSH minus SR into AHW. SR into RSH minus SR into AHW. The last one is labor idle time variance. Labor idle time variance. SR into AHW. This comes XR into AHW minus SR into AHP. Minus SR into AHP. Now let's solve it. SR into SH minus AR into AHP. 2100 adverse. Labor rate variance SR into AHP minus SR into AR into AHP. 3200 adverse. Labor efficiency variance SR into SH minus SR into AHW. Where is SR into AHW? Favorable 2492. Favorable. Labor yield variance SR into SH minus SR into RSH. Favorable. Labor mix variance SR into RSH minus SR into AHW. Favorable. Labor idle time. Usually idle time will be negative, adverse only. SR into AHW minus SR into AHP. Negative. Because of idle time, we are getting unfavorable impact, right? It is adverse. So now how you will read this? So the overall cost variance of labor is 2100 adverse, of which the major contributor is only due to the rate variance. We have to check why the labor salary wages is paid higher than the standard expected. And in efficiency, there is favorable impact. So the labor have worked better, so their efficiency is good, of which the actual real efficiency, the yield variance is 1440 favorable, so they really worked hard. And the mix variance, right, due to the mix in the composition of the labor, we see slight increase in the favorable impact of 752. And we have certain idle breakdown because machine breakdown of 12 hours. Because of the machine breakdown, there is an adverse impact of 1392. Okay, because of the machine breakdown, there is a 12 hours idle time. Because of that, we see an unfavorable impact of 1392 adverse impact. Okay, this is how you have to interrupt the results. Any questions in this labor topic? Okay.
Yes, sir.
No, right? Clear, right? Okay. Thank you. I'll just stop the recording for now.